as we saw from our pyramids of energy, biomass, and numbers, energy transfer is never 100% efficient. Most plants are going to convert solar energy into glucose with only about a 2% efficiency. Herbivores only use around 10% of the total plant energy they consume, and it's 10% every trophic level after that. The rest is going to be lost in metabolic processes. So your carnivore's efficiency is around 10%, and if you have a top carnivore. So if I want to calculate what this carnivore in this scenario's total efficiency is, I would take the 2% of solar energy times the 10% of plant energy times the 10% of the carnivore's efficiency. So of the total sunlight or solar energy that the plant received, you can see that only about 0.02% of that incoming solar energy that went into the grass is passed along to the carnivore. The rest of the energy was dispersed into the surrounding environment. So only a very small part of that sunlight that reaches the Earth's surface and our primary producers is transformed into energy, because at each stage along our food chain, at each trophic level, we're losing that energy as heat due to respiration. Also, we're losing matter to our decomposers, which is going to be recycled back in our nutrients. Some of the energy that was converted by our primary producers, as it's converted into glucose, is stored as chemical energy in the organic bonds. And then some the plants are going to use themselves. They're not going to pass along all of the solar energy because they need energy for their own processes. So the term that we use, the rate at which these primary producers convert solar energy to chemical energy, is gross primary productivity. They store that chemical energy as glucose, so it adds biomass to the plant. That's how plants grow. Now, the biomass that is left after the plant uses it for itself, so the biomass that is passed along to the carnivore or the consumer or herbivore, depending on which trophic level you are, that is net primary productivity. So gross primary productivity is solar energy that's absorbed by the plant and converted into chemical. Net primary is what is passed along to the next trophic level. So in a food web, we can assume that the energy that's given to an organism is gross primary productivity. And then what's output to the next trophic level is the net primary productivity. So the difference between the two is going to be respiration. So if you're ever asked to calculate gross or net primary productivity, if you do the gross primary productivity, so in this case that would be the solar energy, minus the respiration from the plant, that gives you the net primary productivity, or the amount of energy that is passed along as glucose to the next trophic level. So what I want you to do, and we'll look at these first thing in our next class period, is to determine what is the gross primary productivity of an ecosystem if its net primary productivity is 1,660 kilojoules per meter square per year, and the energy lost during respiration is 573 kilojoules per meter square per year. Also, try this one. What is the net primary productivity if the gross primary productivity is 2,700 kilojoules per meter square per year, and the energy used in respiration is 1,850 kilojoules per meter square per year? Now, there are several different factors that can affect the productivity, and productivity is the amount of energy that's converted by your primary producers. So the amount of solar radiation, because you need the solar energy to produce the energy. So closer to the equator, you're going to have the most solar radiation. Temperature also plays a role, so warmer temperatures, you're going to have more plant growth than you would at colder temperatures. The amount of carbon dioxide, the amount of water, the nutrients that are available, and herbivory, which remember that is when your herbivores eat your plants. Instead of calling that a predator-prey relationship, we call it herbivory. So if we base on those factors, the least productive ecosystems are going to be those that have limited heat, limited light, limited water, and limited nutrients. Whereas the most productive ecosystems have your higher temperatures, lots of water, lots of light, lots of nutrients. So our tropical areas are our most productive ecosystems. In the oceans, it's actually the opposite in terms of temperature. You still need your nutrients, but in your colder regions, you have upwelling of nutrient-rich water, which is where the nutrient-rich water from the bottom rises to the top, and we tend to have more productive regions.